You're looking at the future. This is Rocket M, resource or concentrator using kinetic energy targeted mining.
Rocket mining is addressing some key technology gaps for NASA for reliable, sustainable, and ongoing extraction of lunar ice and volatiles from the south pole of the Moon.
NASA's Break the Ice Challenge is a scenario in the Aitken Basin near the South Pole. They have modeled an in-situ resource, 132,000 square meters of icy regolith, 0.2 to 3.5 meters deep, and grading 4% and 10% in two zones. The resource, nearly 70 million kilograms of water ice. NASA's challenge to our team, recover a minimum 10,000 kilograms of water. Let's go to the Moon! Our team, Masten Space Systems, Lunar Outpost, and Honeybee Robotics have put together a complete package to accomplish NASA's mission and to address technology gaps. Here you see our lander touching down at the NASA delivery site. The rover, made by Lunar Outpost, is secured to the top and ready for deployment. This rover is the platform for transport and operations. It can negotiate the rugged terrain between delivery and excavation sites. It may charge its batteries at NASA's 10-kilowatt power plant at the delivery site and the power distribution point near the excavation site. The fully loaded rover, including 300 kilograms of ice, weighs 1,118 kilograms and can travel at 3.3 to 3.45 kilometers per hour. It can easily negotiate steep slopes, such as the 15 to 20% inclines as it makes its numerous 4-kilometer trips from the delivery site to the excavation site. The fuel system components and batteries for the equipment are aft on the rover. The Rocket M system is located mid-chassis, visible as a reinforced dome. The lower part of the dome is deployed during mining to secure a seal and capture icy regolith. Honeybee Robotics PlanetVac icy regolith handling system and the Aquifactorum ice beneficiation system are mounted forward. Containers below deck store ice for delivery. As the rover approaches the excavation site, it is guided to predetermined mining blocks selected by Masten's geologic team. Mining begins with parking the rover over the target area. The dome is deployed to create a seal between operations and the icy regolith. The Masten rocket fires a series of half-second pulses that fluidize the icy regolith, breaking it apart and releasing icy grains. The fluidized icy regolith fine fraction is conveyed into Honeybee Robotics' PlanetVac pneumatic system. This rapidly transports particles into the Aquifactorum beneficiation system. Particles pass over a magnetic separator, then into a pneumatic cyclone, and magnetic and more dense material is taken out. The remaining material passes over an electrostatic sorter to remove additional conductive grains, further concentrating ice particles. The remaining high-percentage ice separate is then sent through two additional pneumatic cyclones, the first removing any additional dust and the second upgrading the ice and sending any gaseous components over cold plates to recapture rocket plume gases and any sublimated ice. The process is fast, being completed in 5 to 10 minutes. Non-ice fractions are exhausted via a tailings pipe to the lunar surface. Masten has conducted firing tests and crater generation in frozen regolith simulant to confirm the viability of the Rocket M system. The craters are rapidly excavated to 2 meters. Although the resource extends further, the Rocket M system will generate significant volumes of water ice product. For the long-term operations, Rocket M is projected to mine 3 craters per hour at 4 sites per day. That's 12 craters per day, allowing for the rover's round trip back to the delivery site and melting of ice into water. We anticipate an 85% recovery of ice, and that will give us 100 kilograms of ice per crater. Over our 355-day operating year, the program will recover 426,000 kilograms of ice annually. This is 43 times the NASA target of 10,000 kilograms. Here you see the rover utilizing the lander for ice concentrate and melting of ice to water storage, where it can be distributed to NASA and other companies. Rocket M is low maintenance, energy efficient, low payload weight, versatile and robust, and is projected to be profitable. Rocket M can be an asset for the cislunar economy.